In this video, we'll be discussing the derivatives and integrals of vector functions, and what you'll find is all you have to do is differentiate or integrate component by component, since the vector function is basically nothing but a triple of functions of one variable. So let's start with differentiation, so derivatives. This for a vector function RT its derivative is usually denoted by dr over dt, or if you want to have a even shorter notation, r prime of t would be the derivative of our vector function rt, and the way it's defined is the usual limit definition of the derivative. What it is you take the differential quotient, so basically take the difference of two outputs which differ only by a small nudge in the input, so you add to t a small number h, and then you take the difference, divide by that small nudge in the input, and let that go to 0. This way you get the derivative of your vector function, and indeed it can be computed component by component, this limit. So basically what you get for the derivative of a vector function is just differentiating each component, provided that they are differentiable functions, but in every example we'll consider you will have that provided. Okay, so let me ask a question, which is to compute the derivative of the following vector function. So I'm giving you the vector function with its components, and it has the three components: 1 plus t cubed, t times e to the minus t, and sine of 2t. Okay, and I'm asking you to compute the derivative of RT. Okay, pause the video and input your answers below. Okay, I hope you paused it. So let's just differentiate component by component. The derivative of the first function with respect to t, well, is 0 plus the derivative of t cubed, which is 3 times t squared. The derivative of the second component, which is a product of two functions, using the product rule for functions of a single variable, we can just compute by taking the derivative of the first factor times the second factor, so that's 1 times e to the minus t, and add to that the product of the first factor times the derivative of the second factor, which is just e to the minus t times minus 1 by the chain rule, because the derivative of the exponential function is itself, but there is minus t in the exponent whose derivative is minus 1, so that we have to multiply with. Okay, so that's the second component, and the third component is, again, we can apply the chain rule to first compute the derivative of the outer function, the sine function, whose derivative is the cosine function, so that gives us cosine of 2t, and then the inner function 2t gets differentiated to the number 2, so that's a factor of 2 coming from the chain rule. So what we have for this derivative is 3 times t squared is for the first component, then e to the minus t times 1 minus t for the second component, and twice the cosine of 2t for the third component. Okay, so I hope that was clear. Now, once we know how to differentiate a vector function, we can talk about the unit tangent vector. So that's denoted by capital T of little t. So the unit tangent vector is defined by taking the derivative of our vector function. So this is a vector itself, taking the derivative of the vector function and rescaling that to be a unit vector, and that is, as you know, can be done by dividing the vector by its own length. Okay, so that's the unit tangent vector at t, at little t. Okay, so for example, for this function, you may compute the unit tangent vector by taking this derivative of RT and compute its length, the square root of the squared sum of components, and then divide this derivative by that expression. Okay, so and as for differentiating still, just like we've seen that differentiating, all it means is taking the derivative component by component. For that reason, the same usual rules of differentiation apply. So we have the sum rule, we have the constant multiple rule, and then we have product rules, because you can form different products of functions or vector functions using the dot product or the cross product. All these identities can be found in the textbook. And then just to say a few words about integration, so that's quite similar. So integrating a vector function is again done by component. If you remember what an integral is just a limit of a Riemann sum, of a sum, where which we could do component by component. And so for that reason, all that it is just the integral of each component. If the components of RT are f, g, and h, as we've seen before, then the integral of such a vector function is as follows: the integral of the first component times I, the integral of the second component times j, plus the integral of the third component times k. Okay, so each component, for the integral of each component is computed. So for that, let me give you a second question. My second question is for you to compute the integral of the space of the vector function whose components are 2 cosine of t, just sine of t for the second component, and finally 2t for the third component. So what's the integral of this vector function? Pause the video and input your answer below. Okay, so if you compute the integral of each vector, what you'll find is that the integral of this vector function is twice the sine of t, because that whose derivative is exactly twice the cosine of t for the first component. For the second component, we get minus the cosine of t, because that gets differentiated to the sine of t. And for the third component, you get t squared, because the derivative of that is just 2t. So this certainly differentiates into that vector function. So it could be a answer, but any constant vector that we would add to this function, so any constants in these components, additive constants, would give you the same answer. So just like in single variable calculus, when we had this constant of integration, here we also have this constant vector of integration. So I hope you enjoyed this video, and I'll see you in the next one.